Assalamu alaikum. My name is Jial Haq Jidan. My ID is 1913544. Welcome to my assignment presentation. In today's video, I will cover single round of DES algorithm with code implementation. So without further ado, let's get started. So at the very beginning, we have to know what is DES algorithm. So in the right side we see a diagram that shows the DES algorithm structure. Today I have to create a single round of DES. So we all know that DES is 16 round, but today I have to cover only one round of DES. For only one round we have to structure a code according to this algorithm. So let's start. So here in this algorithm we know we need a 64-bit of plain text and a 56-bit of key. So here let's see in this algorithm. First we need 64-bit of plain text, and this 64-bit of plain text will splitting into two part. First part will go to left side, that is 32-bit, and the second part is go to right side, that is 32-bit. And this is same for the key, and in this key we know we need 56-bit of key, and this will also split into two part. That one part is 28-bit, that will go to C, and the second part, that is 28-bit, that will go to D. Then after splitting the key bits, then it will go to left shift. This is same for the C and D. C will also go to left shift, and also D will go through left shift. Here 28-bit will go to left shift, then it will merge. After merging, the key will become 56-bit, and it will go to permutation choice 2. Before permutation choice 2, the left part of key, which is 28-bit, it will go to C1, that is for the second round, and same for D. Before permutation choice 2, the left part of the key, which is 28-bit, also go to D2, that is for generating the second round. So here in permutation choice 2 will generate the bit of 48. This is a key bit for 48, and this 48 bit will go through XOR in the Feastor function. So now see what Feastor function is actually. Here in the here we see the text is splitting into two parts, that is right and left and right. In the left part there is 32-bit, and in the right part there is 32-bit also. In this case the right part is actually same to same will go to the next round, that is in the left part for second round, and in this round the left part will go through XOR, and the remaining output will be the right for next round. So in the Feastor function, the output from the right part will go through extended permutation, cause here we need 48-bit. Here we see our key is 48-bit, but here the text that is come is 32-bit. So we need to convert 32-bit into 48-bit, and it is done through expanded permutation. So After expanded permutation, we get 48 bit and 48 bit of text, and from the permutation choice 2, the key is also 48 bit. So now we operate XOR. So these two will go through XOR function, and after XOR we have to run this output through SBox, because we have to get 32 bit, but here is 48 bit, so we have to reduce the bit size, and this will generating through SBox. So after passing the output through SBox, we will get 32 bit of string. Then it will go through general permutation, and we know general permutation is actually remain the same size of the string. Then the output that is given from permutation, general permutation, that is 32, and the left side string, that is 32 bit, will go through XOR, and after XOR function this will generate output that will go to the right part, which is for the second round. And I already said this round right part will go through directly to the left part for the second round. So here is the algorithm that I described. Now I will describe this algorithm according to code. So here is my code. So in this code I actually create function for each rounds and call it to the main function. So let's start with the main function. Here it is. Here in main function we need, I said before that we need 64 bit of plain text, so we have to take 64 bit of plain text. So here I take 64 bit of long text as a input. Here I only write that enter 60 character long text, because we know one text is 4 bit, that's why 16 character is 16 into 4 equal 64 bit. So according to this I actually write this, and then I also take it for the key. Here mainly key we need 56 bit of key, so I actually write enter 40 character long key, because we know one character equal 4 bit, that's why 14 character, 14 into 4 equals 56 bit of character. So here actually I take plain text and the key for algorithm. Then I take the round number, which round the user want to see. Then wait a minute. Then here I actually generate key. Here in key generation I take the bit into input into decimal to binary for calculation purpose. Here in the algorithm we see that at the very beginning the splitting will occur, because we split 56 bit of key into 28 bits. Here I also do the same. Here splitting will occur. Here I run a splitting code. Actually here left and right splitting are occur, and here's the range. A splitting will start from 0 to 28 and 28 to next 28. After splitting we have to go through left shift. For shifting, here I write a code that actually shift our code. Here I want to show something that here for round 1, 2 and 9 and 16 there will be a 1 bits will rotate, and for the rest of the round there will 2 bits of rotation. So let's back to the code. So here shifting will occur. Then after shifting, we have to go through permutation choice 2. So I write a permutation choice 2 values that I found in the book. Here it is. Actually I write by following this. Then but before permutation we have to combine the left shift values, actually merge left shift values. Here I merge left and right shift values in combine and pass the value to combine. Then we permute the value in permute function, which I written before. Here it is. Here in this function actually permutation will occur. It is basically a array type working will occur here. And now actually after that I mainly convert the key size from binary to decimal, and here is the implementation for key. And now we will see the implementation for Feastel function and for the left and right side. And this is the code for encryption, that is we will see in the next code for Feastel function which I write. So let's see. Oh sorry, I forgot to show that here I create a decimal to binary code that will convert decimal to binary easily. And here is another code that will convert binary to decimal, which I mentioned before. Actually these are the functions. Then this permutation function I already covered. And here shifting, for left shift, here is the function which I write. Here shift left function will generate shifting. Then go to our Feastel function process, how it works through code. Let's see. Here in the very first part we see there is a splitting occur, that is 32-bit, and here in the very beginning we convert the plain text, we convert the bit which actually get to decimal, then decimal to binary form. Actually we take decimal to binary form. Then after getting the binary part, there will be splitting will occur, and in splitting there 64-bit will split into two parts, that is 32-bit and 32-bit. One part will go to left side and one part will go to right side. This actually done according to splitting, and then actually start the functionality of Feastal function. In the very first, we have to expand permutation. Expand permutation cause we need 48-bit. Here we have 32 bits, so we need 48 bit. That's why we go through expand permutation. And here is the expand permutation box which I found in the book. So let's see where it is. Here it is, expand permutation. Here is the box. So here is the value I entered. Then, and here is also the value table for S box that is mentioned here in the box, and here it is. Here is the values, and these all are needed for doing this algorithm actually. So let's jump into our algorithm. So here we have to do expanded permutation, and then and here we write a string, write a function for calculating the output for expanded permutation. Here is the code, and after that we will have to do XOR. For XOR, I write this code. Here I call the XOR function that I written before. Here is the code. Here is the code. Here actually XOR operation is done. After XOR, we have to pass our output through SBox. Here in SBox, actually, suppose we have the binary like 1 0 0 0 3 6 7. Here our row is 1 7, and our column will be 0 0, then 0 3, then 6. According to this value, after converting this binary to decimal, we will find a value from the SBox, which I written here, and according to this SBox calculation will done. After SBox calculation, we will go through the general permutation which I mentioned before, and here it is. I actually write this code for general permutation, which here I actually call the permute function. Then we have to do a XOR. In XOR, actually the output of the general permutation and the left bit string output will both go through this XOR. Mainly left part is string value and the general permutation value will go through XOR. In XOR operation, here actually I call the XOR function, which is which I write before. Here it here it is. Here actually XOR function, XOR operation will occur. After XOR operation, there will be a I actually swap the values, cause we know the left part, the output of the left part is will go through XOR, and the output of the right part will directly go to the left part of for the next round. Here actually I write the same. Here I actually swap the left value, swap the right value directly for the left part of the second round, next round, and the left part will go through XOR, then the output will go to the right part, that is right part for the next round. So here is the total code implementation that I written for this algorithm. Now we will see the output for this code. So let's see the output. It take time, please wait. Here is our console. Here we see it says that enter 60 character long text in decimal, cause I mentioned before that one character is 4 bit, that's why 16 character is 64 bit. So let's enter 16 character long text. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 16. Okay, then enter 14 character long key. I mentioned before that one character is 4 bit, that's why 14 character is 14 into 4, that is 56 bit. We need 56 bit, so let's enter 14 character. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Here is the 14 character I entered. Then enter a round number. So let's see the code for round 2, and here it is. For round 2, after splitting, the left side string value is this, and the right part value is this, and I said that the right side value will directly go to the next round left side, and the left value will go through XOR, then it will go to the right side for the next round, and this right side will directly go to the left side value for the next round, which is 3, and this binary value will equivalent to this decimal value. Actually here left and right value is shown in decimal, and we take the next round value for binary. Here it shows the 32 bit of binary for left side, which is the binary of this decimal number, and the right side binary will show which is generated from the XOR, here it is, and the round key, which is shown here 56, which is shown here the it is shown here the 56. We all I actually generate this into binary form, that's why it shows in binary. So here is the small presentation for my code implementation according to this algorithm. So thank you very much for listening. Have a good day.